Hi, I'm John Hartmann, the digital editor for Chess Life Online and uschess.org. Today we're going to be talking about Leela Chess, how to install it on your computer, how to make sure you're downloading the best version for your hardware, for your particular hardware needs, how to install it and configure it in your interface of choice, and how to understand its output. The occasion for this is a book review that I wrote for the April 2019 issue of Chess Life. You can see it on the screen in front of you. It was a review of the rather interesting and really important book Game Changer by Matthew Sadler and Natasha Regan. So Game Changer is about AlphaZero, which if you haven't heard of it, AlphaZero is a self-learning neural network-based chess engine that took the world by storm in December 2017 when it was revealed that this algorithm, which only knew the rules of chess, only knew the basic rules, through 44 million games of self-play and through tuning of its neural nets, within 9 hours became the strongest chess-playing entity on the planet. Now, the 9 hours is a little bit misleading. It was running on massive parallel hardware. If you tried to duplicate this on your home computer like I might do here, it would take you years and years and years. That being said, still an incredibly impressive accomplishment. And one of the really interesting things about Game Changer is that it not only focuses on the technical aspects, so it gives you a very good layman's overview of the difference between an alpha beta engine like Stockfish and a self-learning neural net like AlphaZero, but it also shows you the games, and it shows you the imaginative, beautiful attacking chess that AlphaZero played. As I said in the review, it's almost like AlphaZero plays like humans wish they could if we were as strong as computers. It seems to understand something like what Kasparov meant by quality. And given the history of computer chess, that was pretty surprising. So if you're interested in computer chess or artificial intelligence, or if you just want to read a book that has some really good chess games in it, definitely consider picking up Game Changer. I think it was excellent. But one of the things I said at the end of the review is that for all of the promise of AlphaZero, there is no indication that anyone outside of Google or DeepMind is ever going to be able to use it. I think that ultimately, like Deep Blue, it's going to be walled off in a proprietary castle, never to be seen again. And understandably, it's based on proprietary software. You can't release that. I get that. But from the perspective of a chess fan, and as someone who is very interested in computer chess, it's a bit of a disappointment. Luckily, there is an open source project, Leela Chess, which I talk about at the end of the review, that is based on the principles and even the pseudocode behind AlphaZero. So Leela Chess, for all intents and purposes, is as close as we're going to get to AlphaZero without having AlphaZero itself. And that's part of what makes it so interesting. What I want to show you today is really how to get it running on your computer, how to do it in the most effective way, and how to understand what it's trying to tell you. So, on the screen in front of you, we have the Leela Chess LC0 homepage. Don't worry about any of the links that you're going to see here. They will all be provided in the article on uschess.org and in the supporting material on YouTube. So what you see in front of you is a progression bar as the self-training and self-tuning of the Leela Chess networks goes on. Right now we can see that over the past 3 million games, it has made steady, if not linear, improvement. That self-training, by the way, is going on computers all over the world. Google was able to provide the DeepMind people with all the hardware they needed. Leela Chess, because it's open source, doesn't have access to that sort of resources. So chess players all over the world, chess fans, perhaps even just random people interested in AI, they're donating time on their computers to help make it work and to do the self-training. And it's progressing at a speed of approximately 13 games per second. So if you're interested in doing that, you can read the materials on lczero.org. I'm not going to go into it here today, but it's not very hard to do if you do want to get involved. Now, let's say you want to get this thing running. So what do you need? If you go to the Get Started page, you will see that there are 3 components really three parts to this puzzle that need to be acquired. The first is the engine, AlphaZero.exec. This is a UCI compliant chess engine. It will run in ChessBase or ChessX or Chess Assistant if you happen to use that. It'll run in any interface that can read a UCI engine, and it will follow UCI commands. So if you know anything about the protocol, you're good to go with this. You're also going to need to download a network, and I'll show you how to do that in a moment. The third part is the client. The client is what you will use if you are interested in helping with the self-training. Both the engine and the client, so the AlphaZero and the client.exec, they're both downloadable in the releases. So if you go to releases, if you go to releases, as you see here on the Get Started page, there are three different versions of this you can download. And really the choice here depends on what sort of hardware you have. Traditionally, chess players haven't had to worry about this too much. Every chess engine is usually run on the CPU, the central processing unit. So if it could be an i3 or an i5 or an i7 if you're an Intel person, or if you have an AMD chip, it might be a Ryzen chip. But Leela Chess, like AlphaZero, runs on your graphics card because it requires different sorts of mathematical computations to really function. So there are three flavors you can download, and they're sort of based on what sort of hardware you have and how you want to do it. If for some reason you want to run it on your CPU, you can download the BLAS version. That stands for Basic Linear Algebra Subprograms. In essence, it's a very inefficient way of translating the sort of mathematics that is done on the GPU to the CPU, and you lose a lot. So even on my 8-core machine here, it's only looking at approximately 175 to 200 game rollouts per second. Game rollouts, what I mean by that, Leela Chess, like AlphaZero, it's not looking at individual positions, it's looking at game continuations. It's spinning out games from different points in its search tree and trying to evaluate which moves are most promising in those positions. So it's a different way of approaching the search problem. The BLAS version is very inefficient. As I said, it's looking at approximately 175 to 200 positions per second on a relatively fast 8-core machine. So unless, you may have a reason for wanting to do this, but I don't recommend running it on your CPU. If you have an AMD video card or an Intel integrated video card, you're going to want to use the OpenCL version, OpenCL standing for Open Compute Language. It'll run fairly well here, but if you happen to have an NVIDIA card, definitely download the CUDA version of Leela Chess. CUDA, Compute Unified Device Architecture. Why I'm giving you these acronyms, I don't know, but I felt it was important. OpenCL, by the way, Open Compute Language. It's NVIDIA's own internal proprietary architecture for doing math on a GPU. And it'll allow you to speed things up dramatically. On my GPU, I have an RTX 2060, which is a fairly new video card. If you're looking for one, by the way, I certainly would recommend it to anyone who's looking for the best value for their dollar for Leela Chess. It'll run you about $350, but it is the lowest priced one that has Tensor Core technology, and Leela, as part of this CUDA compile, is able to make excellent use of the this Tensor Core technology. The OpenCL version, when I run it on my GPU, it'll roll out maybe 1,500 to 1,700 game continuations per second. The just unconfigured out-of-the-box CUDA version will run about 5,500 to 6,000 game continuations. And if I configure it to use those Tensor Cores using FP16 mathematical features, it'll be over 20,000 rollouts a second. So there's a dramatic difference. Basically, take a second, try to figure out what kind of hardware you have, and then download the best flavor of this according to your needs. So you do need to download one of these zip files. You also need to download a network. And so you can get to networks here on the home page. And let me see if I can, hello, there we go. All you have to do to download a network is just click on one of these files, and it will start downloading, and it will download to somewhere on your computer. When it is done downloading, I've already downloaded it, so I don't need to do it again. You're going to want to take that, and you're going to want to put it in a folder somewhere with the stuff that you downloaded in that zip file. So here, this is that CUDA version. I've taken everything that was in there, I've put it in a folder that says CUDA, and I've taken that weights folder, the weights file, the network file, and thrown it in here as well. That's all you need to do. You don't need to change any names. You don't need to configure anything unless you want to. If we just click on this, it'll run right out of the box. This is the UCI engine. It'll look much better if you put it in an interface. So to do that, let's go ahead and do this. Now again, keep in mind, to make this all work, you need to download one of these 3 files, decompress it somewhere on your computer, and put the network that you downloaded into that same folder. So right now, for example, I've got all of that on my D drive. You can see this right here. And so I've got all the materials that were from that zip file. I've got the weights, the neural net. And I'm going to go into ChessBase now, and I'm going to try to install this. So to install an engine in ChessBase, you need to have a game window open. I've got this file of Soviet Championships open. Let me just pull up a game here. Petrosian, no, that's a little short. Aronson, Keres, sure, why not? I'm going to go to Home. This is in ChessBase 15. I'm going to create a UCI engine. I'm going to have to open up the folder where I think this engine is. It's in my D drive, a folder called Leela. Okay. And I'm going to click on AlphaZero. That's the engine I want. When you are doing this, particularly if you have a new NVIDIA card, an RTX 2060, 2070, or 2080, it's going to be really important to do this next step. Click on Parameter, and then you're going to want to tweak a couple things. First of all, the back end is what's important for the new RTX cards. You can the CUDNN is good for pretty much any NVIDIA card, I do believe, but the CUDNN-FP16, that's really the one you want if you have one of these new NVIDIA RTX cards. Threads, that's the number of CPUs that that Leela Chess will use to feed it game continuations and help it work. There is no reason to have more than 1 or 2. Not 23, 2. The neural net cache size, you can easily add an extra 0 on here, assuming you have more than enough RAM. Mini batch size, that's a different UCI option that I think deals with how many rollouts it can do at any given time. You can try this. You can try different values. I found that 512 or 1024 is probably best. Everything else in here is okay, but if you do want to ever tweak any of these, I'm going to make this okay, and then we're going to go into it in a second. But if you ever do want to tweak any of these, you can always look at the technical explanation of Leela Chess. This is a very nice webpage. Again, you will have the link. You don't need to write anything down. And they'll show you a glossary of all the different terms, so you can try to figure out how you might configure it to your heart's content and try to squeeze out the most game rollouts per second. There is a German chess forum that does have a lot of discussion on this. If you can read German, great. If not, Google Chrome will do some translation for you. And I got some really good ideas about how to tweak it myself here, so I will include this link as well. At any rate, let's see what happens when we turn it on. So let's go to Add Kibitzer, and let's go up to LC0 right there, and let's see what happens. So, hello? Are you working? Ah, here we go. All right, so we can see, and I'm going to make this font bigger. Can I make this font bigger? Choose font. There we go. Yeah, we can see pretty quickly that it's rolling out approximately, what, 19,000 game continuations per second. And it's giving you an evaluation of 0.35 allegedly centipawns. Now, if I turn on Stockfish here, and I'm not going to put Stockfish on anything very fancy. But if I turn on Stockfish, just put it on 2 cores. Stockfish gives evaluations in centipawns, meaning that it's telling you that right now it thinks white is approximately zero point 0.2 pawns better than black. Um, Leela Chess is giving you the same sort of output, but it's translating game rollouts, percentages, into that particular format. So if you're ever interested in knowing exactly what the format is, again, you can go to that technical explanations page, and they show you that Leela Chess is converting its expected score into centipawns. So if it thinks it's going to win 50% of the time, it'll say that the evaluation is 0, 0, 0. If it thinks it'll win 55% of the time, it'll return an evaluation of 0.45. If it thinks it'll win 75% of the time, it'll say it's up 2.84, so forth and so on. The reason this is important is that people get very confused by the differing evaluations here. So if we go somewhere in the middle of the game, see if we can find something dramatic. Yeah, so maybe even here. Stockfish is evaluating the position as approximately a pawn and a half in black's favor. Leela is giving it 0.223. When you watch computer chess aficionados, watch the games that were played, for example, in the TCEC Championship or Chess.com Championships, they get very excited about the difference in evaluation. And the important thing to understand is that they're telling you two different things. Stockfish is saying that it thinks it's approximately 2 pawns better here. Black is 2 pawns better. Leela Chess is thinking that, that if we translate it back, that it's approximately 70% of the time that black is winning. And, I know Jennifer Shahade talked to Natasha Regan about the 000 phenomenon in Stockfish. And the more I think about what they were talking about and some of the things that were mentioned in the Game Changer book, this way of thinking about things that Leela Chess has, thinking about it in terms of win percentages, might be a really, really interesting way to try to evaluate positions. If a position is one that might be objectively drawn according to best play, but only one side has chances to win, I think that requires a different sort of evaluation than a simple 0, 0, 0 from Stockfish. And the great thing about Leela Chess is that it might help you try to understand how that works. I know this is quite a bit of wordiness for trying to understand this, but the difference in evaluation really, really is important to understand. Just randomly, again, we'll just pull up a different game here in the Soviet Championships from 1957. One other thing to mention as we're looking at how this works, Leela Chess does require some game history to accurately assess a position. It has to fill its history planes. It's part of the way the network works. So if you want to get a truly accurate understanding of what it thinks, you need to go back a few moves in a position and then play up towards it. Let's see what's going on here. Typical Najdorf, H6. I guess in particularly complicated positions, it's the evaluation function may slow down, but again, as we go deeper and deeper, the rollouts per second does seem to perk up a bit, looking at Leela Chess. Yeah, you see it goes up the further we go. So it thinks right now both sides are pretty equal, chances are equal. G5, suddenly both sides really interesting, Stockfish likes it a little more. Takes, rook G8, oh boy. Bishop E2. See if we can get a big difference here. It appears knight G6 is a mistake. Stockfish likes knight F3, although I'm only running it on 2 CPUs. How is white going to win this game? Bishop E7. Rook F1, okay, bit of a mistake. Knight takes E4. Bishop to H5. Takes E3. Well, knight takes E6, complicating things immensely. All right, so this is a position where it's interesting to sort of see what's going on. Stockfish and Leela both think that that black should capture back. But after queen to c4, 0-0-0 by Stockfish, meaning it sees a draw somewhere in there. But you notice Leela is slightly more optimistic, and that has to do with the difference in the way that they're analyzing. Stockfish has found a repetition. It thinks that's the best play for both sides, especially for white in this position. So it So it thinks that the repetition is best. Leela is taking a sort of an average of all the game rollouts, giving us the highest percentage rollout here is the top line, but it's giving us an average of all the rollouts that it sees, and so it must think here that there are some winning chances, however minuscule they might be. Bishop takes. Knight d1 would be better, it says, and I guess this might actually peter out to a draw. Knight to g7. I guess knight to g7 keeps winning chances alive as opposed to rook f4, maybe? Anyway, so I guess knight d1 would have been better. Knight e2 appears to be a mistake. Knight e2, king b1. Bishop c8, counterpinning. But there's a tactical problem. Take knight g7, king f8. Oh, yeah, bishop takes. And now bishop f5. Yeah, interesting game. This may seem a little extraneous to have looked at this, but it's very important, I think, if you're going to use Leela, to try to understand what the difference in the output is. Again, Leela, when it's giving you this, plus 32 number, that doesn't mean it thinks it's 32 pawns ahead. What it means is that it thinks it's got a winning percentage somewhere between 95 and 100%. So you might even want to print this out if you're going to use Leela a lot. I think it's actually very, very handy to have on hand. But it's really, it's very, very important to recognize the difference here. And once you recognize that, Leela may be a really useful analytical tool for players who are, doing deep analysis of positions that Stockfish just gives triple zeros for. It also, it's a different style. And certainly, chess could use some more adventurous ideas in the age of our metal friends. So definitely, as a way to sum this up, I definitely think you should give Leela a try, keeping in mind all the things we talked about here. In particular, making sure that you download the right version for your hardware. Again, the NVIDIA card, if you happen to have one, definitely download the CUDA version. AMD or Intel video cards, the OpenCL version is probably best. If you have to use it on a CPU, use the BLAS version. You also have to download a network, so please do make sure you download that and include that in the file where you have unzipped everything else. And then you should be able to configure it in ChessBase. In particular, the back end, you want to make sure you configure that properly if you have an RTX card. The neural net cache size, you can at least make that 2 million instead of 200,000. And the mini batch size is something you can experiment with. A lot of the ideas, again, came from that computer, the German computer website. I'll give the link as well. You can read that and translate into English if you need to with Google Chrome. At any rate, after many, many aborted takes, this video is finally done. So I hope it's useful. Please do come back to uschess.org to keep up with all your chess news needs, and we will do our best to fulfill them. Thank you very much, and have a good night.